Welcome back. The learning objective of this video lecture is to understand the importance of establishing many regional value chains of photovoltaics around the world to meet the commitments of the Paris Agreement. We have discussed earlier in this course the various CO2 reduction scenarios to combat climate change and to meet the targets of the Paris Climate Agreement. The blue lines correspond to the CO2 reduction scenarios that limit the increase in global surface temperature to 1.5 degrees Celsius, the light blue line, and 2 degrees Celsius, the dark blue line, in reference to the temperature in pre-industrial times. This can only be realized if we drastically redesign our energy system into a future energy infrastructure in which fossil fuels are replaced by renewable electricity. Wind and solar energy is directly converted into electricity using wind turbines and photovoltaic modules. The entire energy value chain is predominantly electrified to decarbonize the industrial, residential, transport, agriculture, and public sector. In the IPCC reports on mitigation of climate change 2022, this bar graph was published. The graph shows the potential contribution to net reduction in CO2 emissions by 2030 per technology. The length of the bar shows the amount of net reduced CO2 emissions expressed in equivalent CO2 emissions per year. The colors along the bars represent the cost per additional reduction in net emission. The blue color represents that the corresponding technology is cheaper than the reference based on CO2 emitting fuels. The graph basically shows that wind and solar energy are the technologies that on short term can have the biggest contributions to replacing CO2 emitting energy technologies with renewable electricity. In addition, these technologies are for a large part, see the blue color, cheaper than the fossil-based technologies. This fully supports the results of the earlier discussed model entitled Global Energy System based on 100% renewable energy. This model simulates global energy transition for all regions in the world in detail from 2015 towards a 100% renewable energy system in 2050. Note that this model does not need carbon capture in the second half of the century to meet the targets of the Paris Climate Agreement. The model shows that to realize a 100% renewable energy system, the role of wind and solar electricity has to grow significantly. 80% of the energy in the form of renewable electricity is supplied by wind energy and 69% by solar energy. Let's look at this projected global needed capacity in wind and solar power for 2050. As earlier discussed, using this graph, solar and wind capacity needs to maintain an exponential growth of its annual market up to 2030-2032 to establish the required annual market needed for the next 25 years after 2030 to realize 69% share in the total mix of power capacity. It means that in 8-10 years, an annual market of at least 3 terawatt peak should be realized. In this graph, the realized cumulative installed PV power up to 2021 is shown, represented by the yellow bars. Note it is not effective power, but the rated or nominal power installed. The red bars show the annual markets of added PV capacity. This trend has followed for the last 2 decades an exponential trend. However, the annual markets, the red bars, do not seem to follow an exponential trend anymore in the last years. Let's go back to the previous graph. The gray symbols represent the effective wind power and the orange symbols represent the evolution of the effective photovoltaic power. Note that the open orange circles are the forecast of the annual markets for the upcoming years. A side note should be that in the last 20 years, market forecasts structurally underestimated the real annual markets realized. The red dashed line corresponds to the trend to establish a 3 to 6 terawatt annual market within 10 years. Even if the orange trend is an underestimation, the black arrow shows that we are at risk to deviate from the needed red exponential growth trend. What is the limiting factor to further exponentially growth of the annual photovoltaic installation market? The main reason is that the supply chain of production of modules and photovoltaic system components are mainly produced in one single region in the world, China. This supply chain is still growing, but its growth is limited due to many financial and physical limitations like circularity, material supply, and logistic limitations to distribute PV systems around the world. This graph demonstrates that the world is in need of establishing regional supply chains. This means that PV modules and system components need to be produced in South America, in North America, Africa, Middle East, Australia, Europe, and all over Asia. Everywhere around the world. A 3 to 6 terawatt market cannot depend on a globally supply chain dominated by a single region. It needs regional supply chains. It means that the governments and the financial sectors in many regions need to change their mindset and set the policies and investments in place to realize a quick upscaling of the regional supply chains. It is needed to mitigate climate change. In summary, I hope you understand the importance of establishing many regional value chains of photovoltaics in the world. Only with regional value chains we can meet the commitments of the Paris Agreement. The future energy system is based on renewable electricity generation, transport and storage of energy, and efficient energy consumption. It starts with establishing sufficient capacity in renewable electricity generation. I hope you will help us to establish this needed growth. And see you in the next video.